Hello and welcome to SketchUcam version 1.3. The major new feature in this version is ramping. As you can see from this image, a simple cut becomes seemingly more complex, but in harder materials this is much easier on the tool bit and the machine in general, because the tool enters the work gradually. As you can see at the start of the cut, it ramps down at the limiting angle. It will do enough of those ramps to limit the angle to less than or equal to the value you have set in the parameters dialog using these options here. We'll then cut at the depth specified in this simple drawing. It's a full depth cut till it gets to the tab, rises to the top of the tab, ramps down again on the other side and completes the cut. In summary, plunges are replaced with ramps. Both arcs and lines can be ramped, as you can see in this image. Those are helical arc segments going in each direction till it reaches depth. The plunge feed rate is used for the ramps. Plunge bores use the ramp angle for the helix angle, and segments less than bit radius long will not be ramped. There has to be a limit as to what can be ramped. Very, very short segments don't make sense for ramping. However, a comment is output into the G code which says ramp limit end translated to plunge. This is to alert you that there is a plunge in your file, and if your tool bit and machine cannot plunge, you need to look at your code carefully before you cut it to make sure that there are no translated plunges in your code. This is up to you. The software cannot do this for you. The two basic options with plunging are to have a limiting angle. Many insert tool types are limited to 5 to 10 degrees of plunge angle because of the geometry of the tool, in which case you need to use that angle. Other tools are not limited in terms of angle at all, and you might want to cut with ramps but with no actual limit on the angle, in which case you can enter a limit angle of 0. Note that for short segments the angle can become quite steep if you do this. So if you are operating in hard materials, be very careful to set an appropriate plunge rate, which is the feed rate used for the ramping movements. Normal feed rate is used for all other movements. Let's just preview this code quickly with no ramp angle limit. As you can see, the short segment has not limited the angle. If you have a situation where you have a rather long segment, which is the first segment to be cut, because the slower plunge feed rate is used for that, you might want to shorten that segment. The way to do that is quite simple. You select tabs, you place an ordinary tab on the line, and then remove it, regenerate G code, and you can see that it now uses a short ramp. Because we have not limited the angle is quite steep on a short segment. If we now change the angle, 0 is unlimited, 1 to 45 is a limited angle. Regenerate that G code. And we can see that because of the limited angle, it has now generated multiple passes to achieve the depth of cut. You can also see in the code itself we have a comment telling us that ramping is on and that it is at 5 degrees. And if you look at the code itself, these codes here are those ramp motions. Tabs will of course be ramped after their motion, as can be seen there, using the current limiting angle. All plunge movements will be ramped. Therefore, we can see that in even something like a pocket, so here you can see the entry to the pocketing. This area here is ramping in, and once it gets to the end of the zigzag, it ramps into the outline of the pocket. Plunge hole helixes are limited to the ramping angle or half bit diameter per pass, whichever is less. This prevents uncommonly large ramp angles in some situations. Let us place a large hole here. Let's go a little bit larger than twice bit diameter. Another improvement in the G-code generated by SketchUcam 1.3 is that the helical arcs output for plunge bores are no longer a single full rotation, but are done in quadrants. The reason for this is that some G-code interpreters sometimes miss a complete arc from a helical bore. In hard materials, this will definitely break your tool, because it will plunge to the start of the next bore and start the helical bore at that point, which will be an entire multipass depth deep and getting deeper as it goes along. So we don't want to do that, and so we've had to change to quadrants, which forces the software to reliably detect the arc segments. Arc segments are tricky in G-code because of the sine and cosine singularities at 90 degrees and 180 and other mathematical mumbo jumbo. As you can see in this code, that is a complete circle to that depth, and so it goes. So you can see it has bored that 8mm hole without a central plunged hole. It starts with a 2 times bit diameter hole, helically bored, and continues with the final size. Naturally, it is still using the step over percent, and if you have fuzzy hole boring turned on, it makes sure that all the passes are the same size, either using larger than step over percent if it's above 50%, or less than step over percent if it is less than 50%. 50% has been chosen as the breakpoint to determine an assumption of hard material or soft material. If the step over is higher than 50%, the assumption is that it is a softer material, and we can go a little bit more on the step over if necessary to get equal step overs in the helical boring. If it's less than 50%, the assumption is that it's a hard material and we should err on going to a lower step over. If the step over percent is exactly 50%, then exactly 50% will be used. This means that, for instance, cutting a odd-sized hole that is a multiple of the bit diameter plus a fraction, the last pass will be that fraction of a bit diameter deep. This may be a good thing, and it may be a bad thing for surface finish. I've spoken about shortening long ramps already. Just add a tab and remove it, and that breaks the line, and so the first segment will cut in a short piece. Multipass ramping. After a pass that has cut to a depth after the tab, the next pass will rapid down to almost that level and begin a new zigzag ramp. This makes it much faster in cutting. I've already mentioned the V-tab tool somewhere. V-tabs are useful on straight lines when ramping, but not so useful on arcs. The arcs end up to being too short to maintain the correct ramp angle, and I recommend using normal tabs on arcs when using ramping. The ramping in plunge holes maintains the angle that you have set. This means that small diameter cuts need more passes to maintain the angle than large diameter cuts. And so you can see in this little picture here that the inner cuts have more turns than the outer cuts. This is normal. There is some complicated logic going on internally, and you can read the help if you really want to know about the finer nuances. It uses the step over percent to decide what to do with the material for holes that are larger than bit diameter but less than 2 times bit diameter. Since you can cut a 2 times bit diameter in one helical bore, you can cut smaller holes in one helical bore. But if you have hard material, maybe you don't want to do that. And so by setting step over percent to less than 50%, you can choose that it does an extra internal pass before doing a final pass. With step over percent larger than 50%, it will simply helical bore the hole in one go. Holes greater than 2 times bit diameter will always be helical bores, the initial hole being a 2 times bit diameter, and after that we'll be using step over percent to set the pass widths. And it will also use fuzzy hole stepping to make the steps all the same size to be more efficient for odd-sized holes.